In 2.9, we're going to be looking at something called implicit differentiation. So far in Chapter 2, for the majority of Chapter 2, we have been doing explicit differentiation. So when y is a function of x, we just use explicit. Implicit is when y is not a function of x. And this comes into play like we were seeing with our parametric equations, but it also comes into play when y is not by itself. That's really one of the issues we have, because some of these problems we're going to look at, yeah, we're smart. We could get y by itself. But other problems we're going to look at and go, it would be more difficult for us to get y by itself than to just straight do the derivative with what is given. And so what I want to do is I want to work some examples with you. I'm going to give you some pointers along the way, and then from there we're going to see kind of this process. So just kind of hold tight with me, work through examples with me, but then when we finish this entire lecture, if you still feel lost, please reach out and I'll be happy to help as much as I can. And so what we're going to be doing is we are going to be taking the differentiation with respect to x. You saw in the previous section that we were doing it with respect to time, and you saw some fractions appearing. Same is going to be here, but it's going to be kind of in a less situation. So first equation says, let's take the derivative with respect to x of y cubed. So if we're taking the derivative with respect to x of y cubed, first thing you're going to do is follow all derivative rules that you know. So I'm going to bring the 3 down. I'm going to subtract 1 from it. But because I'm taking the derivative with respect to x and my variable is a y, I now need to include a small little fraction of dy dx. Again, this goes back into play with what we saw with our parametric equations, but it also really relates to our chain rule and the fact of we are working from the outside in. We are bringing the 3 down, subtracting 1 from it, times the derivative of the inside, and the derivative of that y is dy dx. Now, all I need to do to finish out that problem is clean it up or simplify it if possible, but there's nothing more I can do to that, so that would be my final answer. Let's do it again and add in some pieces. So with this next one, we're going to be taking the derivative with respect to x of x plus 3y. So first we're going to start with x. The derivative of x is 1. We're doing it with respect to x, so we do not need anything else. Plus 3 is going to go along for the ride. The derivative of y is dy dx. And I'm done. I can't simplify it anymore. I'm done. So you can see when I'm taking it with respect to x, anything that is not an x variable is going to have a fraction. Let's go to the next part. The derivative with respect to x of x y squared. So we're going to have to do product rule. Here's our first function. Here's our second function. So we're going to do the derivative of the first. So the derivative of x would just be 1 times the second y squared, plus the first, which is x, times the derivative of the second, so y squared. We're going to bring the 2 down, subtract 1 from the exponent, times the derivative of y, which is dy dx. Now we're going to clean this up as much as we can. So this would be y squared plus 2xy dy dx. Just kind of putting things in order, and having a multiplier times 1 is not going to make a difference. Let's keep doing this. I'm going to keep kind of escalating the difficulty of some of these problems. This one says find dy dx given y cubed plus y squared minus 5y minus x squared equal to -4. So case in point, me trying to isolate y, get y by itself so I could do explicit differentiation would be a waste of my time, and I probably would get lost in the algebra of it all. But this wants us to find dy dx, so we're going to have to use implicit differentiation, and we're going to have to move some stuff around and actually do some more simplifying. And so what I want to do is I want to work this example, and then I'm going to give you guidelines or some step-by-steps to help you with any given problem. So let's do this. This says find dy dx. That means, hey, I need to find the derivative. So I'm going to start with the first term. The derivative of y cubed is 3y squared dy dx plus y squared, which is 2y. The derivative of y is dy dx. Minus the derivative of 5y, which is 5, dy dx. Minus x squared, we're taking it with respect to x, so it's just 2x, equal to 0. So that is my raw derivative. Now I have to clean it up, and here's how I'm going to clean it up. I'm going to move everything that doesn't have a dy dx, which I've conveniently placed in red, to the other side of the equation. And you can see that this is the only term that doesn't have a dy dx. So I'm going to move it to the other side. Just to move it, basic algebra, I'm going to add 2x to both sides. So now I have 3y squared dy dx plus 2y dy dx minus 5 dy dx equal to 2x. So I have all terms, here's my equal sign, on the left side over here with dy dx's. Now left or right, doesn't matter, just all of the terms of dy dx on one side. The reason I'll do this is because they all share this piece of information, I can factor that out. So I'm going to pull a dy dx out of each term, and that's going to leave me with 3y squared plus 2y minus 5 equal to 2x, because my goal was to get dy dx by itself, find dy dx. So now that I have factored out that dy dx, this is dy dx times this whole grouping, so I'm going to divide by that whole grouping. If I do it on one side, I have to do it on the other side. And so this would cancel, and I'm left with dy dx equal to 2x over 3y squared plus 2y minus 5. And so you can see the more complicated problem we have here, but it also goes through the instructions of find dy dx, and I found what dy dx was equal to. So we're going to take this step by step, and we're going to write the steps you can see coming up. And so first, you're going to take a raw derivative. You're going to take the derivative of the whole thing. 2, you're going to move all terms with dy dx over to one side. 3, you're going to factor out and solve. And so let's kind of write those steps down in your notes here. So again, guidelines for implicit differentiation. 1, differentiate both sides of the equation with respect to x. Every y gets its own dy, quote unquote, dx. And so this is where you're just taking that raw derivative and getting that first part. And testing wise, grading wise, this is what's going to give you partial points. You got the raw derivative. The next set of partial points is that you could get it all by itself. The next set of partial points is you were able to factor it. And then you're able to solve it. So part 2 says collect all the terms with dy dx on one side and move everything else to the other side. And it doesn't matter which side you're trying to isolate that dy dx, do the one that's most convenient. And step 3, factor out your dy dx and solve for dy dx. And so you can see that in our steps above. So now that we kind of walked in the shallow end with some y's, and then we worked with this large one. We've got our guidelines. Now let's just start going through some examples, applying these 3 steps as we go. So here's the first example. Find dy dx given 2y squared plus 5xy minus x cubed equal to 15. So the first thing I'm going to do, I'm going to take a raw derivative here, and anytime I take the derivative of y, I'm going to throw in a dy dx. So first one, 2y squared, its derivative would be 4y, and then the derivative of y would be dy dx. Now the next one has 2 parts. It has a 5x and an x, so you're going to have to apply a product rule. Be careful that you're not doing this all in one swoop, taking the derivative of each piece, because that is a product, so product rule applies. So I'm going to say plus the derivative of 5x, which is 5, times y, plus, now you're going to move to that second piece, 5x, the derivative of y would be dy dx. So again, this piece here is product rule, and this big chunk is the result. Minus x cubed, which would be 3x squared. I don't need a fraction because it's relation to x, equal to the derivative of a constant is just 0. Now that you have the derivative, just your raw derivative here, now you're going to isolate all the terms that have a dy dx. And so you can see here's a dy dx, here's a dy dx. So I'm going to leave those there, and I'm going to move this piece and this piece to the other side. So that's guideline number 2. Collect all terms with dy dx on one side and move everything else to the other side. So I'm going to minus the 5y to move it over. And I'm going to add the 3x squared to move it over. And so that gives me 4y dy dx plus 5x dy dx equal to negative 5y plus 3x squared. Step 3, factor out a dy dx. You can see in red I have those two dy dx's on there, so I'm going to factor that out. So that leaves me left with 4y plus 5x equal to negative 5y plus 3x squared. Last part, solve for dy dx. So I'm going to divide by 4y plus 5x. Divide by 4y plus 5x. And so I'm left with dy dx equal to negative 5y plus 3x squared all over 4y plus 5x. Be careful with this. Students who understand what's going on and they know how to work the problem typically run into errors with negatives or letters, just slight situations. So if you see that you've entered the answer, you've gotten it incorrect, go back and maybe do your raw derivative again and make sure you have the right pieces to work with in that problem. Let's do another one. Determine the slope of the tangent line to the graph of x squared plus 4y squared equal to 4 at the point. So this one is going to take our implicit differentiation and step it up. Now we're going to do more beyond the basics of the steps. We're going to apply what we know about implicit differentiation in order to get the slope of a tangent line. And so let's see what we can do here. First step, if you're seeing words like slope of a tangent, etc., you need to think derivative. And so because of this wording right here, I'm thinking derivative. Because this problem has y not completely by itself, because of the way it looks, I'm thinking I'm going to have to do implicit differentiation. So let's do that here. The derivative of x squared is 2x. It is relation to x, so I don't need the fraction, plus the derivative of 4y squared is 8y dy dx equal to the derivative of 4, which is 0. So first thing I'm going to do is I'm going to take this and get it by itself. That's step number 2. Collect all terms with dy dx on one side and move everything else to the other side. So I'm going to say minus 2x. So that gives me 8y dy dx equal to negative 2x. And then I'm going to factor out the dy dx, which there's only one term, so I don't really need to factor, but I do need to solve for it. So I'm going to divide both sides by 8y. So this gives me a result of dy dx equal to negative 2x over 8y. Now, the fact that I saw slope of a tangent, I thought derivative, I saw y wasn't by itself, I thought implicit. Now I need to go back and see, what am I going to do with all this? Determine the slope of the tangent line to the graph. Well, dy dx is going to tell me the slope. Now they gave me a point, and this point is going to tell me that this is my x and this is my y. So I can take that information and plug it in here. If you find in a problem as brief as this one that you are not using information they gave you, you're probably not on the right path. So now I'm going to plug in that point. So I'm going to say that's going to be negative 2 times x, which is square root of 2, all over 8 times y, which is negative 1 over the square root of 2. And then I'm going to clean it up from there. So let's see, looking at this, I apologize. We could have simplified here to give me negative x over 4y. So let me just go ahead and make that correction here. So negative x over 4y. Okay, let's first work with, say, writing this out. So this is negative square root of 2 divided by, when I multiply that 4 into there, that's 4 over the negative square root of 2. Remember, when you're working with division of fractions, you keep it, change it, flip it. So you keep the first, change it to multiplication, and flip the second. So this is going to give us, multiply across our fractions. Let's see, negative and negative is going to give a positive. Square root of 2 times square root of 2 is just 2. All over, multiply across the bottom, which is 4. So this gives me 1/2. Now be careful with all those radicals and stuff. Go slow, show your work, just so you don't miss stuff, especially in this one. So now I can see if I wanted the slope of a tangent at that point, square root of 2, comma negative 1 over square root of 2, it would have a slope of 1/2. So you can see implicit and then plugging in and just simplifying it up. Let's look at another one. Find the slope of 3 times x squared plus y squared squared equal to 100xy at the point 3, 1. So again, here's your key points. When you see this word slope of, you want to think derivative. And we're going to look at the equation they have given us. And because this equation right here has y's throughout it, you want to think implicit. And I'm trying to be helpful with how the words are given and what you're supposed to do with it, so that when you're faced with the chapter 2 exam, it's not going to be pieced out, oh, this is 2.9 implicit, but you can go, here's what I have, here's what I know, what do I need to do? So first we're going to do our derivative with implicit, and we're going to go slow, we're going to clean it up and get to a point. Then we'll apply this additional information of the point, because again, one sentence, if you're not using everything in that sentence, you may not be on the right path. So first, let's do derivative. And so this is going to be 3 times x squared, just rewriting, plus y squared squared equal to 100xy. Now let's make some notes here. Notice here, we're going to have to apply product rule. Note here, you're going to have to use your chain rule. So we got to pull out the big guns for all this. Keep remembering everything that we're doing. Whew, let's do this derivative. So first thing we're going to do is the chain rule. So I'm going to bring the 2 down, multiply by the 3. That gives me 6. Leave everything in the parentheses alone. Subtract 1 from that exponent. Times the derivative of the inside. So the derivative of x squared is 2x. Plus the derivative of y squared is 2y. Implicitly dy dx. Woo, that was the derivative of the left. Equal to, we got to do product rule. Now I separated it into products. I'm going to look at 100x as the first function and the y as the second function. So the derivative of the first, which is 100, times the second, which is y. Plus the first, 100x, times the second, y, is dy dx. So that's my raw derivative. Now, you guessed it, we got to clean this thing up. So my goal is, in our guidelines, is to get these dy dx terms all over to one side. But the problem is your left side, it's within a grouping of multiplication. So we're going to have to multiply this out. So go slow and be careful with your multiplication. And so I'm going to first distribute the 6 into here. And so that gives me 6x squared plus 6y squared times 2x plus 2y dy dx. Over here on the right side, I'm just going to bring it along for the ride. It's not causing me any troubles. Then I'm going to multiply or FOIL out the left side. So 6x squared times 2x gives me 12x cubed. 6x squared times this term gives me plus 12x squared y dy dx. Plus, multiply these two, so that's 12xy squared. plus 12y cubed dy dx. Now you can look at this and think, okay, you know, traditional foiling or double distributing, can I put anything together? Well, no, none of our variables are really matching up that you can combine like terms. So I'm going to keep on, I'm going to keep on bringing down this right side. Now that I have this fully multiplied out, I am going to move all my terms that have a dy dx over to one side. And it looks like I have more of the terms on the left side, so I'm just going to move those over there. And so what I want to do is I want to get this term, and this term all over to one side. The easiest thing would be to move this one on the right over here. And so I am going to do that now. I'm going to say minus this 100x dy dx. So minus 100x dy dx, just kind of bring it over here to the side, so that'll move it. Then I need to move the things that are not dy dx over to the other side. So that means this piece needs to move to the right and this piece needs to move to the right. So just minus 12x cubed minus 12xy squared, but whatever I do to one side I have to do to the other, so minus 12x cubed minus 12xy squared. Ooh, that's a mess. Let's see what we got going on here. So we have a negative 100x dy dx plus 12x squared y dy dx plus 12y cubed dy dx equal to, so you can see we have this dy dx, we've got this dy dx, we've got this one. Now let's grab all our terms without dy dx. That would be 100y minus 12x cubed minus 12xy squared. Okay, and so we need to factor out these dy dx's, so you can see there they are. All three terms have that in common, so we're going to pull that out front. So I get dy dx. Let's see, negative 100x plus 12x squared y plus 12y cubed. And that's equal to 100y minus 12x cubed minus 12xy squared. And then divide to get that dy dx by itself. So I'm going to divide both sides. Minus 100x plus 12x squared y plus 12y cubed minus 100x plus 12x squared y plus 12y cubed. And so finally, after all this, we know that dy dx is equal to 100y minus 12x cubed minus 12xy squared all over negative 100x plus 12x squared y plus 12y cubed. So that is my dy dx. Now, the problem asks for find the slope, that's why I did this whole derivative, at the point. So let's pull in the fact of the point is at 3, 1. So this gives us the values of x and y, and I'm just going to plug those in. So the slope would be equal to, so I'm going to write my problem with blank parentheses everywhere I have a letter. This is how I always like to plug in, especially with a difficult plug-in as this. Now x is 3, so I'm going to come back in here and put a 3 everywhere I had an x. And then y is 1, so I'm going to plug in 1 everywhere I had a y. And this one right here is squared. It wasn't very clear that I was writing that. Now, here's what I would do when I would plug this in. In my calculator, I would plug in this exactly like that. And when you do that, that is going to give you equal to negative 260. And then I would go in my calculator, I would plug in this exactly like that. And that's going to give you a value of negative 180. Then I would divide those two and simplify it, and it gives me 13 over 9. And that's how I would plug that in, as not to get some mess up this. But again, the details are what's going to get you there. So problem is more difficult. You're not going to see a ton of these on your exam because you can see how time consuming they can be. But again, going back to your keywords, looking at this, if it says find the slope, you want to think derivative because of what you're given, think implicit, and then don't forget about your 0.31 and finishing out the problem. Okay, let's look at the next one. Find the second derivative implicitly. And so it's the slope of, here's our function, find dy dx and evaluate. So for this one, we're going to have to go through this process. We're going to have to go through it twice. And so your cleanup is what's going to be really beneficial as you do it. So first of all, here's our original function, x squared plus y squared equal to 25. So I'm going to take the derivative. That would be 2x plus 2y dy dx equal to 0. I'm going to clean this up. That's going to be, let's see, subtract the 2x over. So it gives me 2y dy dx equal to negative 2x. Then divide by 2y. So dy dx is equal to, let's see, those 2's will reduce, so it gives me negative x over y. And that's my first derivative. So in order to do my second derivative, I'm going to start there. I'm going to say dy dx is equal to negative x over y. Since we cleaned this up so much, on the left-hand side, that's my second derivative. I don't have to do implicit really on the left. Now on the right-hand side, we are going to have to do quotient rules. So I'm going to do derivative of the top, which would be negative 1, times the bottom, minus the top, be careful of those negatives, the derivative of the bottom, which would be dy dx, all over the bottom squared, and that's your quotient rule. I'm going to leave this left-hand side alone. Clean up the top, that's negative y plus x dy dx, all over y squared. Now, what I need to do is, now that I have kind of this part, I'm going to have to plug in something that I know. I know that dy dx is equal to negative x over y. So I'm going to plug that in. Bringing down, keep it with my notation, that would be negative x plus x times negative x over y, all over y squared. And so now it's all about the algebra. I need to clean this up. So putting this part together, that would be negative y plus negative x squared over y squared. I don't like to leave fraction within fractions. Well, no one should leave fractions within fractions. So what I'm going to do is I'm going to multiply by y over y. And in doing this, it's going to clear out the top fraction and just amplify the bottom, which will be fine. And this is just a big old 1, so that's fine that I'm multiplying by that. So this would be equal to, and I can just bring all this notation down. Make sure your notation is spot on. So y times negative y is negative y squared. Y times this gives me negative x squared because y's would cancel. And then on the bottom I get y cubed. And so this is my second derivative. But you can see that I had to use my first derivative to get there and my first derivative to simplify this one. Last step was to evaluate at the point, a little bit bigger handwriting there, negative 3/4. So this is going to be your x and your y. And so I'm going to plug that into what I just got. So that would be equal to negative something squared minus something squared over something cubed. X is negative 3 and y is 4. And so again, as you saw earlier, plug in everything into in the top in your calculator, get your number. Everything in the bottom into your calculator, get your number. And that numbers would be negative 25 over 64. And so not too bad, but definitely details and algebra. All right, if we're going to talk about this implicit, I know we're getting lengthy here. We need to do one using a logarithm to help us with this. Now you look at this problem, and this is just a regular problem. Y equals to whatever. And our approach to this would be that we would have to do product rule. So the product of this times this. But you can see that this would involve chain and this would involve change. And just thinking about that stresses me out. Like, oh my goodness, all the pieces that would I have with that. With this one, what I want you to do is I want to use what I know about logarithms to help me with this. because I know logarithms has special properties where I can manipulate, expand out, I'm thinking algebra here, but it doesn't have log anywhere. Well, as long as I do it to both sides, I'm okay. So what I'm going to do is I'm going to take the ln of both sides. And if you see me write ln, I always write it in cursive so that I don't accidentally turn into a 1 and think there's a variable in there. So I'm going to ln both sides, and I'm going to call this y. So it gives me ln of y equal to ln of this whole grouping. Let's revisit our algebra days. And if you revisit algebra, I am going to take my log properties and expand this out. So remember, your log properties, your exponents can come out front, you can separate out by addition, your multiplication, etc. So this is going to give me ln y, notation's important here, and this is going to be 3 ln of 4x minus 5 plus 3 ln of 5x squared plus 8. Now, if you forget all your log property rules, you need some review, let me know. I can post that. But now that I have that expanded out, I have 3 different terms. Well, if you recall that if we do the derivative with respect to x of ln u, it was u prime over u. So now when I go to take the derivative with respect to x of this whole thing, on the left-hand side, that's going to give me 1 over y dy dx equal to 3, 4x minus 5 goes on bottom, the derivative goes on top, plus 3, 5x squared plus 8 goes on bottom, the derivative goes on top, 10x. And that is my raw derivative. So now, if I solve for dy dx, because I want to get that by itself, to get rid of this 1 over y over here, I'm going to multiply both sides by y. So the y's would cancel here, and I have dy dx is equal to, now I'm going to clean this up as I go, 12 over 4x minus 5 plus 30x over 5x squared plus 8 times y, scroll up, isn't y equal to all this that we started with? And so instead of y, I could just say 4x minus 5 cubed, 5x squared plus 8 to the 4th. And that went way smoother than what we would have done if we have done product and change. And you would have been wrong, but you would have definitely been not on one screen and working that out. So algebra, 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 details. Let me know if you need assistance with 2.9.